All right. From assignment 1.2, this is Swyk number 1, and kind of a review a little bit for you from one of the previous questions. Find the square roots of 81. Yes, that's the same thing as saying x squared equals 81. I showed you the picture. It looks something like this, where you have the two solutions. So we know that 9 and negative 9 are the answer to this question. Now to continue that, giving you a little bit more background. What if the question had said that we wanted to find, like say, x squared equals 0. X squared equals 0. Well, this picture shows you that there's only one answer to that question. Obviously, the answer to that, when you take the square root, is just 0. Okay, but what if they said something like x squared equals negative 16? Okay, so the temptation is to take the square root and say, oh, it's plus or minus 4, but that's not true. According to the picture, there is no solution to that question. Okay, so if we were to say, find all the square roots of negative 16, the answer would be no solution. Okay, which is why you see there's an answer choice B here that says the square roots are not real numbers. So you would have to pay attention to that possibility. Okay, so continuing on here, but this is the two solution situation, right? Because 49 over 64, now that's obviously a fraction. It's less than 1, but it is a positive number. So same situation, we're going to take the square root of both sides, all right? And really and truthfully, you've got the square root of 49 over the square root of 64. So if you know that you got 7 and 8, you got one positive and one negative, are the answers to that particular solution. Okay, find the real root here. Now this is a different question. This one doesn't say find all the square roots. This one is like saying what is simplify. They should probably say simplify. That would probably be a better way to say this. Okay? So like what if it said simplify the square root of 81, right? Well, then you would say 9, right? Different from the last question. And truthfully, they should have said something like solve. Really, that's what those questions say. They should say solve. Because as I pointed out earlier, didn't make mention of it, but I shouldn't. It did not say simplify the square root of 81. It said, find all the square roots. It's really better if they said solve. Right here, they should have said solve x squared equals 81. That would be a better way to say that question. But this one is a simplified question, right? They want me to simplify the square root of 0.16. Now, at first you're like, oh my goodness, it's a decimal. Why? You can simplify that to the square root of 16 over 100, right? 16 hundredths, that's how we read that, is 16 over 100. And trust me, I know you guys hate fractions, but it's okay. We can look at it as the square root of 16 over the square root of 100. I have a different way to look at this, and we'll show that to you in a little bit. But that would be 4 on the top and 10 on the bottom. As a fraction, it would be 2/5. But they didn't ask for a fraction. If you look at the way they've answered, they basically ruled out. They don't want fractions. They want integers or decimals. So obviously it's going to be a decimal. 0.4 is the final answer for this question. Okay? Yes, I know it's 2/5. But they didn't ask for a fraction. Otherwise, if they'd asked for a fraction, then yes, Math Excel would have wanted 2/5. Okay, same thing here. Square root of both sides. Find the two real solutions. Solve. Square root both sides. Get positive 10 and negative 10. Just don't forget. And they want commas in between. Boy, if it were me, I would just want plus and minus 10, but not them. They want 10, comma, negative 10. Question 5. Find all the cube roots of negative 216. Well, all right, so let's think about y equals x cubed. Y equals x cubed looks like the red shape that I just drew there. And you'll notice every time I draw another horizontal line, it crosses one time. So that means no matter where you are, there is always one solution. So when we say the cube root, find all the cube roots of negative 216, there's only going to be one answer. They could also say solve x cubed equals. Now, we would probably do something like this. We would take the cube root of both sides, right? And that would give me negative 6 as that final answer. For those of you who do not know how to use your calculator to find different roots instead of square roots, because I know there's a square root button, on a graphing calculator, you would type the number 3, okay? So you'd actually type the 3. There's a math button on the left side of the TI graphing calculators, TI 8384s. About the 5th one down, after you hit the math button, it says the xth root, okay? It has something that looks kind of like this. I don't know, it might look like it's a little higher than that, I don't know. Maybe it looks more like x, like this, something like that. That would then, and it will put that 3 in the spot of that x on screen. If you have the older style calculators, the 83s, 83 pluses, it will not look like a cube root symbol. It'll just have the 3 out in front, and then, but you know that that's what the index is. Whereas the scientific calculators actually have this xth root symbol above the caret. You'll need to look for the little exponent caret button. It should be right above that, but you'll type the 3 just like you did with the graphing calculator. Then you'll find that button right there, and then it'll use that for your cube root. And then, of course, you type your number, like negative 216, and it'll give you the value that you need. Okay. Got a few more things to do here, so might go over my 7 minutes today. X to the 4th. Same scenario, right? X to the 4th has a similar shape to x squared. Okay? It's got steeper sides and sharper corners, but, by and large, it's the same thing. So, you can't think like perfect squares. You have to think like perfect fourths. In the next Swyk, I'll show you a little bit more about that. Things that you need to know. So, for instance, when I take the 4th root, don't forget that there's a positive and a negative, and it ends up being 4 and negative 4. This is a simplifying question, right? We know that there's only one answer here. All those cube root things have only one solution to them. So, come down here to negative 512, and then find the answer to be negative 8. Take the cube root. Okay, that's all we got there. Nothing fancy there. Now, getting into fractions, I do want to show you that when you take the cube root of 64 over 512, my recommendation is to simplify the fraction first before you take the cube root. That will come into play later on down the road. So, think about ways to reduce it. Yes, you can go one step at a time. You can take 2, and then another 2, and then another 2, and then another 2, and then if you realize there's a 4, you could take a 4. If you could make the jump all the way, like for instance, what if you looked at it and went, oh, I know 64 goes into 512. Well, guess what? You could skip all this stuff and go straight to here and then say, oh, what's the cube root of 1? Well, that's a 1. What's the cube root of 8? That's a 2. So we have 1 over 2 as our final answer. Okay? Now, we're going to get more into this in the next Swyk, but I thought I would show you a little bit of this at the end of this one. So when you're multiplying radicals together, I know you can't add like radicals, but you can multiply like radicals, or unlike radicals, I should say. The only way to add radicals is if they're like radicals. We'll get into that at a different time. But radical 5 times radical 3. If a perfect square can be created in the process, that would, if you can see it before you multiply together, I'll give you an example here. Okay, I'll make up a new problem, totally separate. What if you had a problem like this, and you saw that 5 times 5 is 25? That would generate a perfect square. And so, instead of putting them together and saying, oh, that's the square root of 75, which we could look at it and say, oh, that's going to be 5. And then, of course, that's radical 3. I think we could get to the answer quicker than if we mashed it all together and then started to think about splitting it up. Sometimes that's the only way to do it because maybe you don't see a perfect square. In this particular case, there was no perfect square being created. 5 times 3, there's no factors that come out of 5 or 3. So, radical 15 is your only answer there. But when you get to something like this, maybe you see, okay, I got a 2 there. you could take that 50 and break it up into 2 and 25. Okay? Now, why am I doing that? Because right here, I'm seeing a perfect square. That's radical 4. Okay? And radical 4, we know that that's 2. We know that radical 25, that's 5. So 2 times 5 makes 10. So that's your final answer on this. Now, I do understand some of you are going to look at me and go, Mr. Staley, why didn't we just take 2 times 50 and get square root of 100? I know that the square root of 100 is 10, and then I could have bypassed all this crap in the middle. I get it. That is a way to handle it. But there are coming problems where the idea of finding that perfect square beforehand might make more sense to you and might be more helpful to you. In this case, smashing it all together was great because 100 is a nice perfect square. Okay, and that's the end of this Swyk. Sorry for going a little long.